All right, guys, this is page 6 of the Mod 5 review. Last page, yay! We can almost go back to our lives. All right, so I'm supposed to be doing these without a calculator. If you remember the directions from the previous page, I'm supposed to be simplifying this without a calculator. So what is the square root of 25? That is a 5 cubed, so this is 125. This one right here is asking for us to do the 4th root of 16, then cube that. So the 4th root of 16 is a 2, cubed is an 8. What if you didn't know this off the top of your head? Let me do that on the side here. If you don't know, then the 4th root of 16 cubed could be 2 times 2 times 2 times 2. If you need to see it this way, let me draw a little line to separate those there. So this is a party of 4, which is why it comes out as a 2. 2 to the 4th is craziness because I made a little typo. Do-overs. You thought you were going to catch me in an error, but ha! I caught myself. Sorry to take away your fun. Okay. Now this one's got a negative exponent, so first thing I'm going to do is just flip it. Can also do the reciprocal within there, but anyway, I like to do it this way. And then that's going to be 1 over the cube root of 8 squared. I come back up here. So what am I doing? What's the cube root of 8? 2 squared is 4. So that one's a 4. Am I right? I got rid of my negative exponent, moved it down. Cube root squared. No, where did my whole fraction go? Look at me. Ah, bless my heart. Isn't it like that? You gotta love me. You have to love me. This is 1 over 4. Unless I just lost my mind somehow. Nope, that's it. Okay. All right, these last 6, we can do this. Uh-oh, we were supposed to do something else here, and I can't remember what it was because these are on here twice. And I don't have that information here, so I will have to tell you tomorrow in class what that one's meant to be, and you're just going to have to live without it. Or E, whichever one. We didn't mean to put the same one twice. We had a typo, so I will have to replace that with something tomorrow in class. Okay, here we go. Solve each of the following and then check for extraneous solutions. So that's not a suggestion. That's not like, hey, you should check. It says check. That means you have to. Most of the time we say you should check your answers because it makes good sense. In this case, it's actually something that you have to do. Okay, so I could have written this with a square root, or I can write it with a 1/2. Either way, the way to undo it is to square both sides. So this is 25 equals, these guys actually make a 1, and so we just get 3x plus 4. And then if I subtract that 4 over, I get 21 equals 3x, so x must equal 7. Now I'm going to check to make sure that that actually works. I don't like the 1/2. I prefer to write it like this. So this is 5. If I put a 7 in there, I get 21 plus 4. So does 5 equal 5? The answer is yes. So this is my answer, and I can box it up now. Okay, so now this one, ew, gross. The easiest way to deal with this one is to, I was going to say, sometimes I like to rewrite them in radical notation, but honestly, this one's going to be easiest just to cube. So when I do that, the 3's make a 1, and I get x plus 2 to the 4th equals whatever 16 to the 3rd is, which I have 0 desire to go figure out. Okay, now it says take the, now I need to take the 4th root. And so this is x plus 2 equals the 4th root of 16 cubed. Now, back at the beginning, instead of just doing this 3 right here, if I had done 3/4 and had a 3/4 over here, I think you would have an easier time seeing how I got to this. I don't know if I should show it that way or not. I can do it down that way on this problem. Anyway, let's see how this goes. this fourth root of 16 is a 2, because this is 2 to the fourth. I will show that for people who I know need to see it. So this is a party of 4, so that gives you a 2, and then now I've got that cube right there, so this is x plus 2 equals 8. Subtract that 2 over and I get a 6. Okay, so now I've got to check, which this looks kind of ugly. So I'm going to put in 8 to the 4 thirds. Does that equal 16? That's the question. That's the cube root of 8 to the 4th. Does that equal 16? This is a 2 to the 4th, so 16 does equal 16, and this one checks. So my answer is actually this right here, not the check. The check is just the check. Okay, now this one over here. So I have a radical by itself on this side and a radical by itself on that side. That's an excellent time to square both sides. And I get 3x plus 13 equals 33 minus 2x. I'm going to add and get 5x plus 13 equals 33. I'm going to subtract and I get 5x equals 20. If I subtract that 13 over, and then I get x equals 4. I'm going to check that. If I put a 4 in, I get the square root of 12 plus 13 and the square root of 33 minus 8. So this is the square root of 25. This is the square root of 25. Does 5 equal 5? Yes. So that works. Okay. Oh, you couldn't see my whole check. Darn it. Sorry about that. I didn't realize. Sorry. Take a quick look at that there. So 12 plus 13. Sorry, that was lame. Okay, hopefully you've had enough time. Oh my god, you can totally pause it. I don't have to wait. Or you can go backwards if you need to. Okay, to see that. So now this one right here, do I want to cube it right away? The answer is no, I don't. I want to subtract 3 over first. And I want to isolate my radical. And you go, well, where's the radical? This is a cube root right here. It's just a different notation. So subtract 3 gives me a 2. Okay. So at this point, I want to raise both sides to the 3rd power. That makes a 1 right there, and I get 3x minus 4 equals 8. Add 4 to the other side, I get a 12, x equals 4. So now we're going to check it and see if that actually works. Let me make sure we're still on the right page here. And I get 3 times 4 minus 4 to the 1/3, plus 3 equals 5. So this is 12 minus 4. This is the cube root, sorry, I cannot write that like that, of 8. I mean, I can, but I don't like it, and it doesn't make as good of sense to me. So I'd rather write that as a cube root personally. So this is 2 plus 3 equals 5. 5 does in fact equal 5. I cannot remember what we actually wanted that problem to be. I will tell you in class, but I will not have it on here. I think it's the one where the extraneous solution does not work. So I will make sure I share that with you. Okay, last question here. This I do not want to deal with yet. I want to get rid of this 2. I want to divide that 2 over. And I'm going to get, if I divide that by 2, what, 125, if I'm not mistaken? Okay. So here's the move that I was talking about that I could have done up here that might have made it a little bit easier, so you're going to get to see it right here. Instead of squaring both sides and then taking the cube root, I can do that all at once by doing that to both sides. Raising both sides to the 2/3. That makes a 1 right here, so I just get an x on that side. Does it all in one step. And then over here, I've got my cube root of 125 squared. So the cube root of 125 is 5 squared, so x must equal 25. Woo, that was slick. Okay, and so now back to the original. which is 2 times 25 to the 3 halves equals 250. I have no idea. Let's see. It looks pretty good. So this is the square root of 25 cubed. So that's a 5. So this is 2 times 125, which does in fact equal 250. Nailed it. Woo! All right, that was it. So look for a new problem here. We need to give you guys one that has an extraneous or solution so that you can see what that feels like. We have not done a good job of giving you some variety that way. So I'm guessing I think that's what that one is. And I will share it with you tomorrow. All right, thanks for watching this far. Study, study, study. Good luck. I hope you nail it. All right, talk to you tomorrow.